In this video, we're going to work a couple of problems where we use implicit differentiation to find the second derivative. If you know how to do implicit differentiation to find the first derivative, then getting the second derivative is no problem. There's just an extra couple of steps you need to do. Okay, so let's start by taking the derivative with respect to x of this entire equation. So what we have is the derivative d dx of x squared is 2x. Then d dx of 4y squared is 8y y prime. And the derivative in d dx of 4 is 0. Okay? Now, solve for y prime. So we've got subtracting 2x from both sides. Now, divide both sides by 8y. And we're left with y prime is minus x over 4y. Okay, so now let's just take the derivative of this equation. Right? So what do we have? d dx of y prime is just y double prime. And now here, d dx of minus x over 4y, we just use the quotient rule. So derivative of the top times the bottom minus derivative of the bottom times the top, all over the bottom squared. So we've got we can factor out a minus 4 and we get okay, but we're not done. Let's substitute for this y prime. Let's substitute this. So we have so simplifying. All right, so we can get rid of this fraction by multiplying this times 4y over 4y. So we've got okay, but what we can see is that this 4y squared plus x squared, that's this. So we can just substitute so what we're left with is y double prime is minus 1 over 4y cubed. Okay, let's find y double prime here. Take d dx of the entire equation. So what is d dx of sine y? Using the chain rule, derivative of sine of something is cosine of that something. Okay, and then times the derivative of that something. Let's put that here. All right, and then the derivative of cosine of x is minus sine of x. This is equal to 0. Right, d dx of 1 is 0. So now solving for y prime. So y prime is equal to sine of x over cosine of y. Okay, so now let's take the derivative again. we've got y double prime is equal to, so the quotient rule, derivative of the top times the bottom minus the derivative of the bottom minus sine y, so it's going to be minus y prime sine of y, right? Times the top all over the bottom squared. Okay, so we've got okay, now let's just substitute this y prime here. So okay. So continuing to simplify. And we notice that sine of y over cosine of y is tangent of y. So sine squared x tangent of y over cosine squared of y. Okay, now to me that seems like a good final answer, but the book continues to simplify. They multiply by cosine of y over cosine of y and get, so cosine of x cosine squared of y plus sine squared of x. So tangent of y is sine of y over cosine of y. So, and then over cosine cubed of y. And this is the final answer the book gives. So I guess you could say this is a cleaner form, more simplified form, maybe because there's more like symmetry with the cosines and the sines. So yeah, that's how you do implicit differentiation with to find the second derivative. You find y prime and then differentiate y prime, and then you're going to get y double prime as a function of y prime, and then substitute in the y prime.